Hello my dear students. So like I said, I am going to continue with the extra questions related to rate of reactions. So in the previous chapter, we looked at some multiple choice type questions where you have 4 answers, you select the correct answers. Here you are supposed to write the answers. So I am sure you all will answer the question first and then you will compare your answer with my discussion. So in this lesson, we discussed about rate of reaction. What is rate of reaction? The amount of change that occurs in a unit time related to a chemical reaction. So when we say chemical reaction, reactants are converted to products. So reactants are used up, products are formed. So the rate at which that occurs is the rate of reaction. And there are 4 factors that affect the rate of reaction. What are they? Surface area of reactants, concentration of reactants, and if they are gaseous reactants, it's the pressure of the gaseous reactants, then the temperature at which the reaction takes place, and the catalyst. And how do they affect the rate of reaction? When a reaction occurs, the reactants have to collide with each other. So if a factor can increase the number of collisions per unit time, then it can increase the rate of reaction. So you are familiar with all these and we discuss some activities as well related to the lesson. So now let's answer the questions. Extra question 2. What is meant by rate of reaction? What I just said. Rate of reaction is the amount of change that occurred in a unit time. So that is what you need to write here. The rate of reaction is the amount of change occurred in a unit time. So it can be either the reactants used up in a unit time or the products formed in a unit time. Then the second question. Build up an equation to calculate the rate of reaction. So how do we build up an equation? Now like I said, when we say the change occurred, how does the change occur? The reactants are converted to products. So either the reactants are used up or products are formed in a unit time. So if you are to build up an equation, you have to say rate of reaction equals reactants used divided by time taken, or you can say products formed divided by time taken. So the rate of reaction can be either reactants used up divided by time taken or products formed divided by time taken. One of the two can be used as the equation to calculate rate of reaction. So in this also you can remember students, we can either fix the time constant, amount of reactants used up in a fixed amount of time, or amount of products formed in a given time period. So there we keep the time constant, we measure the amount of reactants used up or products formed, and then we compare the rate of reaction. Otherwise, you can fix the amount of reactants used. Let's say 5 grams of something reacts, and then you calculate the time, measure the time. So there also you can consider the rate of reaction. Either keep the substance constant or the time constant. You are familiar with that. Then the third question. write 3 factors that affect the rate of reaction. So what are the factors that affect the rate of reaction? There are 4 factors: surface area of reactants, the temperature at which the reaction takes place, concentration of reactants, but it is the pressure if the reactants are gaseous reactants, and catalyst. So there are 4 factors. You can write any 3 factors. So I'll write the first 3 factors. We can say surface area of reactants, temperature at which the reaction occurs, and also, so this is one, this is the second one, then the third one, concentration of reactants, For that, I will write pressure of gaseous reactants. You can also write catalyst. So if we look at all the questions, what is meant by rate of reaction? The rate of reaction is the amount of change occurred in a unit time. Build up an equation to calculate the rate of reaction. Rate of reaction equals reactants used divided by time taken, or products formed divided by time taken. Then write 3 factors that affect the rate of reaction: surface area of reactants, temperature at which the reaction occurs, then concentration of reactants, that is pressure of gaseous reactants, and also you can write catalyst. So you can write any 3 factors. So with that, students, we'll move on to the next question. Extra question 3. Compare the rate of reaction of the pair of reactions given below. So in each question, they have given a pair of reactions. You have to identify the factor that affects the rate of reaction, and you have to compare the rate of reaction. And also write the factor that affects the rate of reaction. You have to write the factor as well. First one, equal size pieces of magnesium with cold water and hot water. So equal size pieces of magnesium means the surface area of reactant does not change. Magnesium has the same surface area. But cold water and hot water, what is the factor? The temperature is different. So when it is cold water, temperature is less. When it is hot water, temperature is higher. So when temperature increases, the rate of reaction increases. So they want you to compare the rate. So their rate, we can say cold water is less, hot water is more. So what will be the observation, students? You all can remember when magnesium reacts with hot water, magnesium hydroxide and hydrogen are formed. So hydrogen gas bubbles are evolved. You can observe the rate of fizzing. So when it is hot water, rate of fizzing will be faster. Gas bubbles will be liberated faster. In cold water, usually you don't see a reaction. So the rate of reaction is high when it is hot water. And the factor is temperature. Then the second one, calcium carbonate chips with dilute hydrochloric acid and same mass of calcium carbonate powder with dilute hydrochloric acid. So it is dilute hydrochloric acid, the same reactant, same concentration, there's no change in temperature, but they use chips and powder. So what is the factor? It is the surface area of reactants. And if it is chips, the surface area is less. If it is powder, the surface area is high. So when surface area increases, the rate of reaction is greater. So here rate will be less when it is chips and high when it is powder, that is calcium carbonate. And there the factor is surface area of reactant. Area of reactants. Then the third one. Piece of zinc with 0.1 mole per decimeter cube sulfuric acid and a similar piece of zinc with 0.5 mole per decimeter cube of sulfuric acid. So there they use zinc, that's the metal, piece of zinc and similar pieces. So then the mass is the same, surface area is the same. That does not change. There is no mention of temperature. Then what is the difference? They use 0.5 mole per dm cube sulfuric acid and 0.5 moles per decimeter cube sulfuric acid. This has less concentration, this has more concentration. So they are changing the concentration of sulfuric acid. So when the concentration is higher, the rate of reaction will be higher. Zinc with sulfuric acid, you all can remember the reaction. Zinc sulfate and hydrogen are the products. So here also you will see rate of fizzing or liberation of hydrogen gas bubbles. That will be fast when they use 0.5 moles per decimeter cube sulfuric acid. So here again rate 0.1 mole per decimeter cube H2SO4 will be less compared to 0.5 mole per decimeter cube H2SO4. And the factor is concentration. Concentration of reactant. You can say reactant or you can say sulfuric acid because you know what the reactant is. So those are the three sets of reactions. First one, equal size pieces of magnesium with cold water and hot water. The rate is less when it is cold water, it is more when it is hot water. And the factor is temperature. Here students, you all don't have to write the answer in this manner. I have written it very short. You all can write it as a sentence also. That is up to you all, as long as you give the correct concept. Then the second one, calcium carbonate chips with dilute hydrochloric acid and the same mass of calcium carbonate powder with dilute hydrochloric acid. So there, when you use chips, the rate is less than using powder. And the factor is surface area of reactants. And the third one, pieces of zinc with 0.5 moles per decimeter cube concentration of sulfuric acid and 0.5 mole decimeter cube concentration of sulfuric acid. So the rate will be less when it is 0.1 mole decimeter cube H2SO4 compared to 0.5 mole per dm cube H2SO4. So the factor is going to be concentration of reactant, or you can even say concentration of reactant, or within brackets we can say sulfuric acid. Sulfuric acid. Because concentration is considered for solution, reactants in the form of solutions. So then concentration of sulfuric acid. So I am sure you were able to understand the question and answer it correctly, students. So with that, we'll move on to the next question. Extra question 4. An activity carried out to investigate the factors affecting the rate of reaction is shown below. So look at the activity. There are 3 test tubes A, B and C. In all those, there are equal size magnesium strips. So the surface area doesn't change, and they have not mentioned anything about temperature. So temperature constant, surface area constant. Are there any catalyst? No. So the other factor is the concentration. So here you can see the volume is the same. In all test tubes, we have the same volume of hydrochloric acid, but in the first one, that is A, water plus only 2.5 milliliters of HCl. So this is 2.5 only. B has 5 milliliters of HCl with water. So here C 7 milliliters of HCl with water. So in A, concentration is less. Compared to that, the concentration of HCl is higher in B. Compared to that also, concentration of HCl is higher in that of C. So here the factor is concentration, and that increases in the order A, B, C. So you all have understood the activity. What will be the observation? When magnesium reacts with HCl, hydrogen gas will be evolved. So liberation of gas bubbles or rate of fizzing can be observed. It will be the highest in C and the lowest in A. So that is the activity. Now you all know the observation and you all know the rate of reaction. So as you look at the question, as you look at the diagram, you have gathered all the information. So it will be easy for you all to answer the questions. First one, what is the factor investigated in the above activity? So I have written that they are concentration of reactants. Concentration of so here I will write it as HCl. Or you can write it as hydrochloric acid. You can also write it as reactant. That doesn't matter. Concentration of HCl. How will you prepare the magnesium strips before adding them to the test tubes? So why do you need to prepare the magnesium strips? We have seen that and we have discussed that. You know, magnesium reacts with oxygen in atmosphere. So when it reacts with oxygen, there is a magnesium oxide layer formed and that forms around the magnesium metal. So you need to clean that magnesium oxide layer. Normally the magnesium metal is shiny, but after some time it tarnishes. There will be a layer of magnesium oxide and maybe sometimes magnesium nitride also. So when you rub it with a sandpaper, the layers around magnesium are removed and you get the pure metal. So that is how you prepare the magnesium strip before the activity. So here we can say magnesium strip is cleaned with sandpaper to remove the oxide layer and get the clean magnesium strip for the reaction. You can stop at that point also. So this is what you need to do before the reaction. If we look at the questions, what is the factor investigated in the above activity? It is the concentration of hydrochloric acid. And how will you prepare the magnesium strips before adding them to the test tube? Magnesium strip is cleaned with sandpaper to remove the oxide layer and get the clean magnesium strip for the reaction. So before the activity you clean it and then you put the clean magnesium strip into the test tube. So those are the answers for these questions, but the questions are continuing. So we'll move on to the next slide. Part 3. So again the same diagram is given to you all students. I have explained this, I have discussed this with you all. So you know what is happening there. Third one, write the observations of the activity. So what are the observations? One thing, you will see the liberation of hydrogen gas, or you can say evolving of gas bubbles. And also you will see a difference. The rate of fizzing will be in the order A, B and C. C will show the highest rate of fizzing. So you will see liberation of gas bubbles and the rate of fizzing will be A, B and C. That is the observation. You don't have to write it twice. You can just leave out the first one. You can only write rate of fizzing and compare that as well, because you all know it is the liberation of gas bubbles. So that is the observation. Then the next one, fourth one. Why do you need to add equal size magnesium strip to all three test tubes? Why do you need to do that? When you have equal sizes, the surface area of magnesium strips are equal. So here we can say, so that the surface area of magnesium strips are equal. So that is the reason why you need to use equal size magnesium strips, to have the surface area of magnesium strips to be equal in all the test tubes. So those are the two questions. We'll move on to the next slide. Fifth one, again the same diagram, we have discussed that. Part 5, write balanced chemical equation for the reaction taking place in the above activity. So you all might think, students, now this is related to the previous lesson. But when you get questions, both are related to chemical reactions. So these lessons are combined together and you will get all these questions together. So if we write the balanced chemical equation, magnesium plus HCl will give rise to magnesium chloride and H2 gas. Is it balanced? No. Magnesium is balanced, but you can see hydrogen and chlorine, here Cl2 and H2. So what do? We put a coefficient 2 in front there. So Mg plus 2HCl gives rise to MgCl2 and H2. That is of course balanced. Then the sixth one. What can you conclude from the observations you mentioned in part 3 above? What were the observations we mentioned? The rate of fizzing, we said liberation of gas bubbles is observed and we compared the rate of fizzing. We said in C the rate of fizzing is high. Why is that? Rate of fizzing is high means rate of reaction is high. And in C there is 7 milliliters of HCl. So the concentration of HCl is high. Because of that the rate of fizzing is high. That means the rate of reaction is high. So in A the concentration is less, only 2.5 milliliters of HCl. So the rate of reaction is low. So from that what do we conclude? When concentration of reactant increases, the rate of reaction increases. So that is the conclusion. When the concentration of reactant, that is here hydrochloric acid, increases, the rate of reaction increases. So that is the conclusion of the activity. When the concentration of reactant, that is HCl, increases, the rate of reaction increases. Is that clear to all students? So I am sure you all also answered these questions correctly. With that, we'll move on to the next slide. Extra question 5. Temperature is an important factor that affects the rate of reaction. So there are 4 factors: surface area of reactants, concentration of reactants, temperature at which the reaction takes place, and also the catalyst. And if they are gaseous reactants, instead of concentration, we consider the pressure of the gaseous reactants. So then, the question. Briefly explain how the rate of reaction increases when the temperature of the reactants increases. How do they increase? When the temperature increases means the kinetic energy of reactants increases. Because of that, they start moving faster. You all know the equation for kinetic energy, half mv squared. So, velocity of particles increases. Because of that, the number of collisions per unit time increases. That increases the rate of reaction. So, that is what you have to explain here. When temperature increases, the kinetic energy of reactants increases. Then the number of collisions per unit time increases. Thus, the rate of reaction increases. So, that is how the rate of reaction increases when we increase the temperature at which the reaction takes place. So, when temperature increases, the kinetic energy of reactants increases, then the number of collisions per unit time increases. Thus, the rate of reaction increases. I am sure you also explained it correctly. So, with that, students, we will move on to the next question. Extra question 6. Add equal volumes of potassium permanganate into 2 equal sized test tubes. So, you know the reaction. Potassium permanganate is a purple color solution. Put a drop of sulfuric acid to both the test tubes. So, you take equal volumes of KMnO4, the concentration is the same amount of reactant potassium permanganate, and to that you put sulfuric acid. Why is that? To acidify the medium. You all know the reaction between potassium permanganate and iron that occurs in acidic medium. So, to acidify the medium, we use sulfuric acid. If you put a drop, that is more than enough. One test tube was heated to a higher temperature. So, that means we are going to observe the effect of temperature on rate of reaction. Clean iron nails equal in size. So, 2 factors, 2 points you need to consider. Clean iron nails, so that there are no other compound, no rust is there. So, the correct proper required reaction will take place between potassium permanganate and iron. And also they have to be equal in size. Why is that? So that the surface area of iron nails are equal. So, we are eliminating or we are making all the other factors constant. We are changing the temperature, but surface area of iron nails are the same, and also they are clean. Volume of potassium permanganate is the same and the same concentration. And here normally we don't use a catalyst. So, clean iron nails equal in size were added to both the test tubes. And the first question. Draw a diagram to illustrate the above activity. So, you need to draw a diagram. You need to show 2 test tubes. We'll draw the 2 test tubes. the two test tubes. Then you need to have equal volumes there. The iron nails. You can draw it more nicely to represent the iron nails. Here I have drawn it diagrammatically. So the important thing is you have to mark all these. Equal volume of acidified KMnO4. So we can say A and B. I can say A, room temperature, and B, higher temperature. So if they have mentioned the temperatures, you can write the values there. But here, since they say one test tube was heated to a higher temperature, I have said room temperature for A and higher temperature for B. So we have included all the information. You show that they are equal volumes, equal size test tubes, and iron nails. Normally, when you draw, that also you can mark. Iron nails of equal size as in A. So that means the sizes are equal. So here also I can say iron nails. Nails of equal size. So we have included all the information. In this also both the nails are of equal size. You can just draw one nail also, that's also fine. It has to be clean iron nails. You can include that as well. Clean iron nails of equal size. Here also clean iron nails of equal size as in A. So all the nails are of the same size, they are very clean, and also the same volume, equal volume of acidified KMnO4, but the temperatures are different. Is that okay, student? So if you have a diagram like this, you even without reading that or even before reading that, just by looking at the diagram, you can get a lot of information. You need to read the question, but when you look at the diagram itself, you can get a lot of information. That is very important, students. Look at the diagram and get the information. So now you have drawn the diagram, you know what you need to include. So if you have left out any simple detail, you need to include it. So that is how you are supposed to draw or illustrate the activity in a diagrammatic form. So with that, we'll move on to the next slide. So the third one, what is the color of potassium permanganate solution? What is the color of potassium permanganate? Purple color. So that is something you all are familiar with, purple color. Then, why do you need to add clean iron nails? Why is that? If there is rust, then there can be another reaction taking place. So, if you use clean iron nails, iron will react only with potassium permanganate. There will be no other reactions interfering with the required reaction. So, that is what you have to say here. When the iron nails are clean, there is only iron and KMnO4 to react with each other. That is, there will be no other reactions. Then the effect of temperature on the rate of reaction of iron with acidified KMnO4 will be observed. So that is what will happen there. Here also, students, there is something else that you need to keep in mind. We add only a drop of sulfuric acid. Now you all know iron is a metal, sulfuric acid is an acid. We use it to acidify the medium. But if you pour a lot of acid, if you add a large volume of acid, then of course, although iron reacts slowly, still it can react with sulfuric acid. So there can be an interfering reaction. So to prevent that only, we add a drop of very small volume of sulfuric acid in order to acidify the medium. So you have to remember that as well. So we need to use clean iron nails. So when we use clean iron nails, when the iron nails are clean, there is only iron and KMnO4 to react with each other. There will be no other reactions. Then the effect of temperature on the rate of reaction of iron with acidified KMnO4 will be observed. So that is why the iron nails have to be very clean. You have to keep that in mind. So with that, students, we'll move on to the next slide. Why do you need iron nails of the same size? Why do you need iron nails of the same size? The surface area of iron nails should be equal. So we can write that. So that the surface area of iron nails are equal. So why do we need to have it equally? If you are observing the effect of one factor, all the other factors have to be maintained constant. So if we are observing the effect of temperature, then surface area has to be constant, concentration has to be constant. If you are using a catalyst, it has to be the same. Otherwise, we don't use a catalyst. So that is how you need to have the two set up in order to observe the effect of temperature. So here we use equal size or same size iron nails so that the surface area of reactants is equal. Then the next one. What is the observation do you expect to see in the above activity? What is the observation, students? Potassium permanganate is purple in color. So when iron reacts with potassium permanganate, what happens? The color disappears. So purple color of potassium permanganate disappears. And the time taken for the purple color to disappear gives you an idea about the rate of reaction. If the time taken is less, rate of reaction is fast. If the time taken is more, rate of reaction is slow. So in the two test tubes, one is at room temperature, the other one is at higher temperature. So when will it be faster? When the solution is at higher temperature, the rate of reaction will be faster, so the color will disappear faster. So you need to write both the observations. Purple color of potassium permanganate disappears with time. So, purple color of potassium permanganate disappears with time. For the disappearance of color, what is the other term used? We can also call it as decolorization. So, in the next one, I will use that term so that you become familiar with all the terms. Time taken for the decolorization of purple color is less when KMnO4 is at higher temperature. Higher temperature compared to room temperature. Compared to room temperature. So, you observe the color change, that is purple color becoming colorless, decolorizing or disappearance of the color, and the time taken for the decolorization is less when the temperature is high. So, purple color of potassium permanganate disappears with time. Time taken for the decolorization of purple color is less when KMnO4 is at higher temperature compared to room temperature. So, that is the observation or the expected observation of the activity. I am sure you all can understand that, students. So, then we will move on to the next slide. So, that is extra question 7. Here again they have given a diagram. You can see pieces of metal. They have shown the pieces of metal, and in all 3 test tubes you can see equal volume of the solution or the other reactant, and there they have given 5 milliliters HCl with water, then 7.5 milliliter HCl with water and 10 milliliter HCl with water. So, as you can see, the amount of HCl changes. So, that means the concentration of HCl changes. When you have more HCl and less water, concentration is more. So, this one has less concentration, this is a little bit more, and this has even more concentration. So, this diagram shows a setup arranged to investigate the effect of concentration on the rate of reaction. Question itself mentions that it is to investigate the effect of concentration on the rate of reaction. So, then we need to answer the questions. You all know the reaction taking place here. If it is a metal with HCl, what happens there? You can remember hydrogen gas is evolved and a salt is formed. So, you will see the evolving of gas bubbles. Rate of fizzing can be observed and compared. So, that is how we compare the rate of reaction. So, the first question, what is the suitable metal to use in this experiment? What is the suitable metal? Normally, to compare the reaction with concentration, and you all know we can use magnesium or zinc, because both these metals react fast with hydrochloric acid. When we say fast, the rate of reaction is somewhat fast, so we can easily observe the reaction. Because when you put iron, it's very slow. It takes a very long time, so it is actually difficult to compare the rate of reaction. But when it is either magnesium or zinc, the reaction is somewhat fast, so it's easy to compare the reactions. So what is the suitable metal to use in this experiment? You can write either magnesium or zinc. So I will write magnesium here. If you all want, you can write zinc. That is also fine. Then the second question, what is the gas evolved near the metal? So you all know whether it's zinc or magnesium, when it reacts with HCl, you will get H2 gas, and depending on the metal. If it is zinc, the salt will be zinc chloride, ZnCl2, and if it is magnesium, the salt will be magnesium chloride, MgCl2. So what is the gas evolved near the metal? That is hydrogen gas. Hydrogen gas. So, 2 questions related to this activity. With that, I will move on to the next one. Then, part 3 of the question. So, we have again discussed the activity before, students. The third part. Write the balanced chemical equation for the reaction of the metal with HCl acid, that is hydrochloric acid. So, I wrote the metal magnesium. If you all write zinc, then accordingly you have to write the balanced equation. So, here of course magnesium with hydrochloric acid, you get magnesium chloride and H2 gas. And we need to balance the equation. Magnesium of course is balanced, but hydrogen and chlorine, you can see 2 chlorines and 2 hydrogens. So, we put a 2 there. So, Mg plus 2 HCl gives rise to MgCl2 and H2 gas. So, that is a balanced chemical equation. Then the fourth one, what is the expected observation of this experiment? So, what is the expected observation? You will see the liberation of gas bubbles and you will be observing different rates of fizzing. So, in which one will the rate of fizzing will be high? When there is 10 milliliters of HCl, the rate of fizzing is going to be greater. 5 milliliter of HCl, rate of fizzing will be less. So, what is the expected observation of this experiment? We can say liberation of gas bubbles, then rate of fizzing, you can write it as FISSING or FIZZING. Rate of fizzing will be slow when it is 5 milliliters. 5 milliliters, then it will be more when we use 7.5 milliliters, and it will be the highest when we use 10 milliliters of HCl. So, that is how you will get the observation. What is the expected observation of this activity? You will see the liberation of gas bubbles, and there also the rate of fizzing or the rate of liberation of gas bubbles will be different. When there is only 5 milliliters HCl, it will be slow compared to the 7.5 milliliter HCl. 10 milliliter HCl will have the fastest rate of fizzing. Then the next one. Give 2 other factors that affect the rate of reaction. So, here what is the factor? That is concentration of reactants. What are the other 2 factors you can think of? Surface area of reactants, temperature at which the reaction takes place, and also you can say catalyst. You need to write only 2 factors. So, here I will say surface area of reactants, area of reactants, and then we can say temperature at which the reaction takes place. One is surface area, the other one is temperature. You can also write catalyst. So with that, students, I will move on to the next question. Extra question 8. It is more efficient to use thin sticks of firewood than using large blocks of firewood. Explain this scientifically. So you can have a log of wood. You can split it into small splints, that is the small sticks of firewood. Small splints burn faster. Why is that? When you split it into smaller pieces or small splints, the surface area of firewood increases. So when surface area increases, the rate of combustion is higher. So it burns faster. That is what you have to explain here. So we can say the surface area of a large block, or you can say log of firewood is less compared to small sticks, or you can say splints. Splints of firewood. Since the surface area increases, the splints of firewood burn faster. So therefore, it is efficient to use small sticks. Therefore, it is efficient to use small sticks. So if we read the answer, the surface area of a large block or log of firewood is less compared to small sticks or splints of firewood. Since the surface area increases, the splints of firewood burn faster. Therefore, it is efficient to use small sticks. So that is how you are supposed to explain. You have to relate it to surface area. So combustion is also a chemical reaction. The rate of burning is the rate of reaction. So when they are small splints, they burn faster because the surface area is higher. That is what you have to explain here. So with that, students, we'll move on to the next question. Extra question 9. Catalysts affect the rate of reaction. That you all know. Catalysts actually increase the rate of reaction. Inhibitors decrease the rate of reaction. First one, what is a catalyst? What is a catalyst? A substance that increases the rate of a reaction without being chemically consumed during the reaction. So that is a catalyst. We can say a substance that increases the rate of a reaction without being chemically consumed during the reaction. That is a catalyst. Then the second one, write two properties of a catalyst. What are the two properties of a catalyst? There are few properties of catalyst. Catalysts are specific to reactions. You all can remember, if it is the Haber process of manufacturing ammonia, it is only porous iron. If it is the production of manufacture of margarine, it is nickel. If it is the manufacture of nitric acid by oxidation of ammonia, it is platinum. Like that, different catalysts are specific to a particular reaction. So, they are specific to a certain reaction. A small quantity is needed enough to catalyze a reaction. If you remember, when we did the practicals, we only use 0.2 grams of manganese dioxide, a very small amount. That is more than enough to catalyze the reaction. So, that is another factor. And also, they are not chemically consumed. They participate in the reaction. That's why they increase the rate, but they are not chemically consumed. Their physical nature can change. Like I said before, if you use a chunk of a particular catalyst, it can become powder. The solid chips, it can become powder. Or the powder, the physical nature can change. But they are not chemically consumed. So, what you take initially will remain at the end of the reaction. So, those are the properties of a catalyst. You are supposed to write two properties of a catalyst. So, first one I will say, catalyst are specific to reactions. Then the second one, a small amount is enough to catalyze a reaction. So, they are not chemically consumed during the reaction. That is given with the definition also, with the explanation what is a catalyst. There also we write it, but that is also a property. You can write that as well. So, there are a few properties. These are two properties that I have explained here. Is that okay, students? So, I am sure up to now you have been answering all the questions correctly. With that, I will move on to the last question of the chapter. Extra question 10. A student carried out the following activity to demonstrate the effect of catalyst on the rate of reaction. So, here the effect of catalyst. Equal volumes of hydrogen peroxide was added into two similar sized test tubes. So, hydrogen peroxide, you all know, they dissociate to give water and liberate oxygen gas. That can be catalyzed by manganese dioxide. And you can remember, sulfuric acid is an inhibitor of that reaction. So, you have to remember all that. When you read the question, you have to recall what you have learned. 0.1 gram of manganese dioxide was added to one test tube. So, here manganese dioxide is the catalyst. First question, write the balanced chemical equation for the reaction of hydrogen peroxide. So, it is a dissociation reaction. Hydrogen peroxide is H2O2. You can remember this reaction. It forms H2O and O2. Is the reaction balanced? No. There are two hydrogens, but there are two oxygens. There are 3 oxygen atoms there. So, normally what do? We put a 2 here. So, the oxygen becomes 4 and hydrogen also 4. So, if you put a 2 there, that also gets balanced. 4 hydrogen atoms, 4 hydrogen atoms, 4 oxygen atoms, 4 oxygen atoms. So that reaction is balanced. 2H2O2 gives rise to 2H2O plus O2, the balanced chemical equation. Then the second one, what is the observation of the above reaction? What is the observation? Evolving of gas bubbles. Evolving of gas bubbles. Evolving of gas bubbles. And also rate of fizzing will be high when manganese dioxide is added to the test tube. So that also has to be mentioned. Rate of fizzing is high when manganese dioxide is added to the test tube. So those are the two questions. Write the balanced chemical equation for the reaction of hydrogen peroxide that we have written, and what is the observation of the above reaction, evolving of gas bubbles, and rate of fizzing is high when manganese dioxide is added to the test tube. So, but here of course, since they have said above reaction, you can only stick to evolving of gas bubbles. Only during the activity, you will be comparing the rate of fizzing. You can just say evolving of oxygen gas. Is that okay, student? So then, what will be the dry mass of manganese dioxide after the completion of the reaction? So, in the question it said 0.1 grams. If you want, you can check the question. There you can see 0.1 grams. 0.1 grams is the initial mass of manganese dioxide. Now, this manganese dioxide is not chemically consumed during the reaction. Why? Because it is a catalyst. So, once the reaction is complete, you filter the solution, you get the manganese dioxide, you have to dry it, and then when you measure the mass, it will have the same mass as before. So, what will be the dry mass of manganese dioxide after the completion of the reaction? 0.1 gram. Now, here you have to look at the term dry mass. You filter the manganese dioxide and you have to dry it completely so that you can show it is the same mass. If there is water, then of course the mass will be different. Then you can't really observe you can't really show that it is not chemically consumed. Then the fourth one, what can you conclude from the above? What can you conclude from the above? Above means this. You get the same mass after the completion of the reaction. So that means the catalyst is not chemically consumed during the reaction. That is what you can conclude. Catalyst is not chemically consumed during the reaction. That is what you can conclude from the above observation. So, I am sure students, you all were able to answer all these questions correctly, and also you were able to understand what I discussed with you all. You would have recalled what you learnt in the lesson as well. So, with that, I will end this chapter, and in the next chapter also, I will discuss some more extra questions with you all.